Spherification by Madison Turley. Almost any drink can be transformed into small spheres that have a gelatinous outside with a liquid center. Just a few key chemicals are needed to do so. However, this experiment is not as easy as it may seem. The pH level has to be just right, and if any step gets thrown off, the experiment will completely fail. Background. The area of food science that explores this is called molecular gastronomy. Molecular gastronomy looks at the molecules in our food and how they are physically and chemically changed. The technique that is used to make food into spheres is called spherification, which is based on specific chemical reactions that take place in certain solutions. The two necessary chemicals involved in this food science are sodium alginate and calcium chloride. When the chemicals come into contact with each other, they form calcium alginate, which is a gelatinous substance. Foods need to have a certain pH in order for them to undergo spherification. If a food is too acidic, spherification will not work well. To solve this problem, sodium citrate is added. When this chemical is mixed with water, a basic solution is created. Because of this, it makes acidic foods less acidic. However, spheres will not form if too much sodium citrate is added. The chemical can bind to, or chelate, calcium and prevent it from playing a role in the spherification reaction. Questions. What consistency will form depending on the pH levels or water temperature? What happened when there was too little or too much sodium citrate added? For each food, what was the pH of the sodium alginate in food solution where the best spheres were made? Were any of the foods tested unable to make spheres no matter how much sodium citrate was added? Based on the results, how do you think adding sodium citrate and changing the pH of a solution affects how well it can become a sphere using this molecular gastronomy technique? Risk and safety. There are very few safety risks to this project. A blender will be used, but that is not a huge safety hazard. All chemicals involved in this project are completely safe to handle and consume. Hypothesis. I expect that if a food has the wrong pH level, the liquid will fall apart when placed in the calcium chloride solution. Next, I predict that adding too much or too little sodium citrate will cause the experiment to fail. I also think that different water temperatures will have an effect on the outcome of this experiment. A neutral pH is 7, so I expect that 6, 7, or 8 will be the perfect pH level for liquids to undergo spherification. Procedure. My first step was to gather materials. Then I made data tables to record my findings. Then I added some water to a jar and measured out my calcium chloride. Next, I took 1/2 cup of 7-Up and added it to my blending cup. Then I measured out the sodium alginate and added that to my 7-Up. Then another 1/2 cup of 7-Up was added. Then I blended it all up. Measured out 1/4 cup of my mixture into a little cup and then tested the pH. It was a little bit foamy. Then I put my solution into a syringe and slowly added droplets into my calcium chloride solution. Surprisingly, spheres formed. I removed one of the balls from the calcium chloride solution and took its measurements. Then I recorded those measurements into my data table. I also made this fun string of spheres. The balls were slightly small, and this is them compared to a regular sized lime. They were pretty small. Then I added some sodium citrate and took the pH of that solution. Then I put it into my calcium chloride solution and took the measurements. Added more sodium citrate, tested the pH, and then repeated my process. This time the sphere was quite a lot bigger. So I took its measurements and recorded them in my data table. More sodium citrate, took the pH, and repeated the process. This time, nothing really formed. All the mixture just kind of clung together and created this kind of sticky, liquidy texture. Next, I was trying balsamic vinaigrette. So I did the whole thing where I blended it all up and then measured out 1/4 cup. Made new calcium chloride solution and took the pH. Added my solution into the syringe and then put droplets into my solution. Nothing formed. It just hit the calcium chloride solution and fell apart. So I added sodium citrate and tested the pH. Once again, did droplets into the calcium chloride mixture. It appeared as if spheres formed, but they really didn't. As you can tell, when they were removed from the solution, the seal broke and there was no sphere. So I added some sodium citrate and took the pH of that mixture. I added the solution into a syringe and then put it into my calcium chloride. This time, spheres actually kind of seemed to form. But clearly, they didn't stick for long. So, more sodium citrate and testing the pH. Once again, my mixture was added into the calcium chloride. Spheres actually formed, so I took their measurements and recorded that in my data table. Next liquid is lime juice. Did my process, added the lime juice, added the sodium alginate, and more lime juice. Blended that mixture up, and as you can tell, it was pretty foamy. So I took the pH and it was pretty low, probably about 2 or 3. Then I added my mixture into the calcium chloride and nothing formed, just kept its same liquidy consistency. So sodium citrate was added and pH tested again. And then, again, put into the calcium chloride solution. Same results. Nothing happened. So, more sodium citrate, take the pH, and back into the solution. It kind of worked a little bit better, but not really. Repeated the process. For the third or fourth time, nothing formed. Results. 7 up. Surprisingly, spheres formed without any sodium citrate needing to be added. However, spheres were still created when 1/8 teaspoon and 1/4 teaspoon of sodium citrate was added. For this liquid, pH levels 3, 5, and 6 were able to form balls, but when the food had a 6.5 pH, the droplets clung together and fell apart. As more sodium citrate was added, the outside coating of the sphere got thinner. Water temperature did not have an effect on the consistency of the spheres. Balsamic vinaigrette. Without any sodium citrate, this liquid was unable to form spheres. 1/8 teaspoon and 1/4 teaspoon of sodium citrate was added, and the dressing still did not create balls. When 1/2 teaspoon of sodium citrate was added, the liquid finally formed spheres. However, they didn't hold their shape for long once removed from the liquid. For this food, pH levels 6, 7, and 8 were perfect. Lime juice. No matter how much sodium citrate was added or what the pH level was, lime juice was unable to form spheres. I tried over 10 times before finally concluding. Thank you.